In today's video, we are going to learn about k-nearest neighbor algorithm in detail. In my previous video, I have explained the concept of k-nearest neighbor, the working of k-nearest neighbor. In this video, we are going to look at a practical implementation of k-nearest neighbor. How exactly you can code the k-nearest neighbor algorithm. So, to make our life a bit easier, I have taken a dataset on which we can perform k-nearest neighbor algorithm. I have taken this dataset from the Kaggle website. It is the dataset on mushroom. We are all aware about mushroom. Not all mushrooms are edible. Some mushrooms are edible, while some mushrooms are poisonous. So, here we are going to use a k nearest neighbor classification algorithm to identify whether a particular mushroom is edible or poisonous. Now, let us jumpstart our analysis. First and foremost, we have to import the necessary libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cborn as sns, import warnings so that if there are any warning messages, we can ignore those warnings. Warnings dot filter warnings, we are going to ignore all the warnings. Now let us run all the standard libraries. Now let us import our dataset on mushrooms. So tf is equals to pd dot read underscore csv, and let's import it. Now let us check the head of our dataset. So df dot head. So we have many columns. We have class which will identify whether and mushroom is poisonous or it's edible. How are we going to identify this, whether it is poisonous or edible? It's based on the cap shape, cap surface, cap color, bruises, odor, gill attachment, gill spacing, and so on and so forth. So over here, our independent variable are all the columns other than the class column. And our dependent variable is nothing but our class column. But over here, there is a problem. If you see, you do not have any numbers over here. And we have understood that our machine only understands numbers. Now, we'll have to convert all our alphabets over here into numbers. How are we going to do that? We are going to do that using label encoder. So, now let us import label encoder from sklearn. From sklearn dot pre-processing import label. Now, if you see, all our columns in our data frame is non-numerical. So, it won't be perfect example for us, but we can all convert all these non-numerical data into numerical data using the label encoder. So over here, we'll be using a for loop because we want to apply this label encoder onto all the columns because all the columns are non-numerical. So how do we do that? For call in df, I will create an object of label encoder because all the time I cannot keep writing label encoder whenever I want it. So I will shorten it and do an LE. So LE is equals to label encoder. That's the object of label encoder. Now we have studied that label encoder does not have an in place equals to true parameter. So we will have to reassign the fit column onto the original column. So df call is equals to le dot fit underscore transform. What are we transforming? We are transforming all the columns. df call. Now let us run this code. Now let us check if we have got back our data frame with numbers. Now let us check the head. So here we have all our non-numerical columns have been successfully converted into numerical columns. So we have transformed our entire data frame. Now our next step is model building. So before we build a model, we have to first divide our data into x and y, that is independent and dependent. So my x is all the columns except the zeroth column. So how do I write it? X is equals to df dot ilook. I need all the rows, but I need only the columns from the first column. I do not want the zeroth column. Similarly, y is equals to df.ilook. I need all the rows and I only need the zeroth column. Now let us run this. Now the next step is to split our data into training set and testing set. How do we do that? We are going to import the train test split from the sklearn.model underscore selection. From sklearn dot model underscore selection, import trade underscore test underscore split. Now I write xtrain, xtest, ytrain, ytest is equals to train underscore test underscore split x comma y. I will give a test size of 30%. You can give any value that you like according to your own needs and according to the data set. So I will specify the test size as 0.3. I will give a random state so that your values and my values can be tallied. So we have successfully divided our data into training and testing. Now we are only left with model creation. And as in regression, the same steps are followed in classification also. First, we will call the model, then we'll create an object of the model, then we will fit the model, and at last we will predict the model. So let's do that. So the first step is to call the model. From sklearn dot neighbors import k neighbors classifier. Remember, our KNN has regression as well as classification algorithms. So over here we have to specify that we are performing a classification problem. So we will import the K neighbors classifier. Now the next step is to create an object of this. So KNN is equals to K nearest classifier n underscore neighbors. So in my previous video, I have explained the concept of this neighbors, why these neighbors are important and how many neighbors has to be chosen. In my future video, I will tell you how exactly to choose the number of neighbors. So as a standard thing, we will choose neighbors as 5. So From five neighbors, we are going to check the distance of the point and then decide whether the mushroom is poisonous or edible. So n underscore neighbors is equals to 5. So our object is ready. Now what is left? It's just that we have to fit this model and then we have to predict. KNN dot fit. We are going to fit this model on X train and Y train. X train, comma, Y train. Finally, we are going to predict y pred is equals to knn dot predict. What are we going to predict? We are going to predict x test. Using the fitted model, we are going to predict the y test and y pred. So here our model is complete. So we have successfully run our model. Now, how do we know that our model is good enough? For that, we have something known as accuracy score. In regression, we had something known as R2 score or the R squared. But over here, for classification problem, we have something known as accuracy score. And like in regression, where your R squared came from the sklearn.metrics library, same way over here, accuracy score also comes from the sklearn.metrics library. From sklearn.metrics, import accuracy underscore score. Print, I'm using an F string, accuracy. So we are going to write accuracy underscore score. Between y test and y pred, how accurately are we able to predict y test? That is what we are going to check using the accuracy score. So we write y test, comma, y pred. Now we are going to run this code. So we get an accuracy of 99.75. What does this score imply? Whenever I have predicted that a mushroom is edible, it is 99.75% times that it is actually edible. And whenever I have predicted that the mushroom is poisonous, it is 99.75% times that it is poisonous. So this way we can find out whether mushroom is edible or poisonous using k-nearest neighbor algorithm. In my future videos, I will explain how to come up with the value of number of neighbors, which is nothing but hyperparameter tuning. So I hope everyone is clear with the working of k-nearest neighbor, the Python code for k-nearest neighbor, and the idea of accuracy score. Thank you.